the exercise related to the moles, that was a last week homework from page 1 to 15. So I'll solve the question. So the first one, a compound X has the following composition. The compositions are given for a compound X is having element hydrogen, phosphorus, and oxygen. What is the empirical formula? How we can work out the empirical formula? If you want to work out the empirical formula, like we have a hydrogen, a phosphorus, and oxygen, there are three steps which we follow. So hydrogen is 3.66%, phosphorus is 37.80%, and oxygen is 58.54%. The first step is divide by atomic mass. So we divide all of them by their atomic masses. So hydrogen we divided by 1, phosphorus we divide by 31, and oxygen we divided by 16. To work out the empirical formula, we first step is divided by atomic mass. So when we divide this 3.66 divided by 1, so what we'll get 3.66. And the second one, the phosphorus is 37.8. So 37.8 divided by 31, which is equals to 1.21. And for oxygen, it is 58.54 divided by 16, which is 3.65. Now, what is the step 2? Step 2 is divide by the smallest value in the combination, or we take the simplest ratio. So which is the smallest value in the combination? So 1.21 is the smallest value in the combination. So we divide all of them by 1.219. So we divide all of them by 1.219. So 3.66 divided by 1.219. That is approximately like 3.00, or I can say it's 3. This is equals to 1, and this is also approximately 3. So what is the empirical formula of the compound? Means it contains 3 hydrogen, it contains 1 phosphorus, and it contains 1 oxygen. That's the empirical formula of the 3 oxygen. That's the empirical formula of the compound. So step 1, divide by atomic mass. Step 2, divide by the smallest value in the combination. And step 3, we take the simplest ratio in a whole number. Sometimes we have to multiply with a number factor, and sometimes we just have to round off. The next is compound Y has an empirical formula of H3PO4 and a relative molecular mass of 98. What is the molecular formula? So how we can work out a molecular formula of a compound? If we need the molecular formula of the compound, the molecular formula of the compound is empirical formula times N. And what is N? N is the molecular mass divided by empirical mass. So empirical formula of the compound is H3PO4. That's empirical formula. Multiply by N. What is N? N is a molecular mass. The molecular mass is 98. Divided by empirical mass. How you can work out the empirical mass? From empirical formula, you can work out the empirical mass. So hydrogen is 1 multiplied by 3. Phosphorus is 31. And oxygen is 16 multiplied by 4. So 16 multiplied by 4 is 64. 64 plus 31. That will make 95, and 95 plus 3 makes 98. So means the empirical mass is also 98. So 98 simplifies as 1. So this will be 1. And when 1 is multiplied, so it will be H3PO4. Because when molecular mass and empirical masses are same, it means the empirical formula and the molecular formula of a compound is also same. So the molecular formula is also H3PO4. The next question related to the moles The question is calculate the volume of 0.0625 moles per decimeter cube of a sulfuric acid. So this is a concentration is there, which completely reacted with 25 cm cube and 0.100 mole per dm cube potassium hydroxide. Use the following steps. Calculate the number of moles of KOH. We have the volume and we have the concentration. So if I have the volume and concentration, you can also use screen annotation to answer these questions. So if I have the volume and concentration, I can use a formula. Usually when we solve the moles question, we use a formula, ratio formula. So if I have the volume and concentration, so I'll use a formula that moles, you can represent the mole by small letter n. So moles equals concentration times the volume. So what is the concentration? The concentration is 0.1 and the volume is 25, but that is in cm cube. Volume should always be in decimeter cube. So divided by 1000. So 0.1. So what we got? We got 0.0025. These are the moles. Deduce the number of moles of sulfuric acid. So how to get the moles of sulfuric acid? So we use a ratio. We'll take a ratio between a sulfuric acid and a potassium hydroxide. According to equation, 1 reacted with 2. So 1:2 is the ratio. If we have 0.0025 moles, how many moles will be there? X. Cross multiply. So this will be divided by 2. So it will be 0.00125. Then we need the volume of a sulfuric acid. Again, we use a formula that moles equal concentration times the volume. So if I need the volume, it will be moles divided by concentration. Moles are 0.00125. And how much is the concentration of a sulfuric acid? That was 0.0625. So when we divide, this will give us the volume 0.02 dm cube. But we need the answer in cm cube. To convert this decimeter cube into centimeter cube, we multiply by 1000. So when we multiply by 1000, it will be equals to 20 centimeter cube. So that's how we worked out the volume of a sulfuric acid which we need. So normally when we solve the moles question, the rule is formula, ratio, formula. This is not a new topic. Some of the students joined after like these moles topic. For them, there will be another session after 20 August or last week of August, in which we'll start the syllabus from beginning. So from topic 1, we'll start again, but not with this group. This group will continue with the same pace. Another group will be there, which will start from topic 1. So the topics which you missed, that will be covered there. The next is calculate the concentration of a sodium hydroxide in grams per decimeter cube when 0.345 grams of sodium is added to 50 cm cube of a distilled water and there is no change in the volume. Calculate the number of moles of sodium added. So first we'll use the first part, we use a formula. We have the mass and we need the moles. So the formula, moles equal mass in gram divided by the molar mass. So mass in gram is how much? 0.345. And what about the molar mass for a sodium? When you check the periodic table, it is 23. So the atomic mass, it's an atom. So that's why in a molar mass, we substitute the atomic mass 23. So when we divide, we'll get 0.015. Then determine the number of moles of sodium hydroxide. How to? So first we solve by formula. The second part we'll take a ratio. So we'll take a ratio between sodium and sodium hydroxide. The ratio between them is 2:2. Because like here 2 and here also 2. So or you can also say 1:1. So if it is 0.015, how many moles will be there? X. When you simplify, you get the same number of moles. Then we need the concentration. So first part by formula, second by ratio, the third again by formula. What formula we'll use? We need the concentration. So concentration is moles divided by volume. So moles are 0.015. What about the volume of a sodium hydroxide? The solution 50 cm3 was there, but it should be in decimeter cube divided by 1000, so 0.05. So 0.015 divided by 0.05, that will give us a concentration which is 0.3. Now, we have to convert the concentration from mole per dm cube to grams per dm cube. To convert the concentration from moles per decimeter cube to grams per decimeter cube, you will multiply by the molar mass, molecular mass. So what is the molecular mass of a sodium hydroxide? You need a periodic table. Sodium, when you check the periodic table, it is 23. Oxygen is 16 and hydrogen is 1. So when you add them, 23 plus 16 plus 1, so the sum will be 40. So what we'll do, 0.3 multiplied by 40. So we got 1.2 grams per decimeter cube. That's how we work out the concentration in grams per decimeter cube. These are the questions from the last week homework. Question 4, a 20 cm cube of 0.1 mole per dm cube hydrogen peroxide is there. Calculate the number of the moles. So how we can work out the number of the moles? How we can work out the number of the moles? We have the volume and we have the concentration. So moles equal concentration times the volume. So we'll just multiply these two. So the concentration is 0.1 and the volume is 20, which is 0.02. So this will be 0.002 moles will be there for hydrogen peroxide. Use your answer, calculate the number of moles of oxygen. How to get the oxygen? Look, symmetry is there for a moles question. We use the first part we solve by formula. The second part we'll solve by ratio. And the third again by formula. So what ratio we'll take? We'll take a ratio between a hydrogen peroxide and oxygen. The ratio is 2:1. So if we have 0.002 moles, it will be X cross multiply. So we got 0.001 moles will be there for the oxygen. Then we need the volume of the gas. So whenever you need the volume of the gas, you need a formula that we have moles equal volume of the gas divided by 24. So if I need the volume of the gas, it is moles multiplied by, the volume of a gas is moles multiplied by 24. So moles are 0.001 and multiplied by 24. So we got 0.024 decimeter cube. That's the volume of the oxygen which will be produced by this amount of a hydrogen peroxide. Next is what will be the effect on the volume if the mass of a catalyst was increased. If you use a catalyst only alter the rate of the reaction, it cannot affect the amount of a product. So that's why there will be no effect. Because catalyst can speed up a reaction but not the amount. Then deduce the volume of oxygen that will be produced by 20 cm3 of 0.2. Before we were having 10 cm3 and 0.1, and now we double the concentration. Like before we were having 20 cm3 and 0.1, now we have 20 cm3 and 0.2. So if I double the concentration, so what will happen to the volume? The volume will also be double. Like here, when we calculate it was 0.024. What will happen to the volume now as the concentration is double? So volume will also be double. So it will be 0.048 decimeter cube. So we don't have to solve anything here. We just have to use our previous answer that the volume as the concentration is double, the volume should also be doubled. Question 5. A barium carbonate decomposed when heated. A student heated 10-gram sample of a barium carbonate until it was fully decomposed. Calculate the number of moles. So, how to get the number of moles of barium carbonate? We have the formula that the moles equal mass in gram divided by the molar mass. The mass in gram is 10. What about the molar mass of a barium carbonate? So for this, you have to use a periodic table. So for a barium is there, which is 111. The mass of a barium, when you check the periodic table, it's 111. Mass of a carbon is 12. And mass of oxygen is 16 multiplied by 3 makes 48. I think 137 is there, not 111. 137 is the mass of a barium. 137 is there, and this is 16 multiplied by 3. So when you simplify, 48 plus 12 makes 60, and 60 plus 137 makes 197. So this will be equals to 197. So when we divide, we got 0.0508 moles of barium carbonate. Calculate the volume of a carbon dioxide gas produced. So how we can get the volume of a carbon dioxide gas? First, we need the moles. Using a barium carbonate, we'll find the moles of carbon dioxide. The ratio between them is 1:1. Like 1 mole give 1 mole. So if we have 0.0508 moles, so this will be X. We got the same number of moles. Now, after getting the moles of carbon dioxide, we need the volume of carbon dioxide. Volume of any gas is moles multiplied by 24. 24 is a molar volume, or volume for any 1 mole of any gas, it's 24 decimeter cube. So moles are 0.0508 multiplied by 24. This will give us answer in decimeter cube, which is 1.22. So 1.22 decimeter cube. The next is student The student add 2 grams of a barium oxide . The student added 2 grams of a barium oxide to produce a water. Calculate the mass of a barium hydroxide that can be made from 2 grams. So how we can work out? The third part, when we talk about the volume of the gas, 3 formulas are there. So when we talk about the volume of the gas, so moles equal volume of the gas divided by 24. So we have the moles and 24 is divided, other side multiply. So we'll get the volume of the gas. Student add 2 grams of a barium oxide to produce to water. Calculate the mass of a barium hydroxide that can be made from 2 grams of barium oxide. So how we can do this? First, we'll find the moles of barium oxide. Or you can also take the mass ratio. Or a simple way, first you can take a mass ratio of barium oxide and a barium hydroxide. Like, what is the mass of a barium oxide? Barium is 137 plus oxygen is 16. So the total mass will be 153. So this mass is 153. And a barium hydroxide is 171. Its mass is already given. So means what is the ratio of the mass for a barium oxide and a barium hydroxide? 153 and 171. That's a ratio. So if I have 2 grams, this will be X. Cross multiply. So when we simplify, so X will be equals to 171 multiplied by 2 divided by 153. This will give us the mass of a barium oxide, which is barium hydroxide, which is 2.24 grams. So Using the equation, you can also take, if the mass is needed, you can take the ratio of the mass. If the moles are needed, you can take the ratio of the mole. The mole ratio is 1:1, but the mass ratio or the ratio of the mass is 153:171. In part C, the student added 2 grams of a barium oxide produced to a water. Calculate the mass of a that we did. That was 2.24. Then the next part, 1.5 gram of a sample of a barium hydroxide was dissolved in water. The total volume of a solution is 100. 25 cm cube of a portion of a barium hydroxide was titrated. Like what we did, let's say we have 100 cm cube of a water. We have 100 cm cube of a water and we add 1.5 grams of a barium hydroxide. And out of this 100, we only took 25 cm cube for a titration. Calculate how many moles of a barium hydroxide are there in 25 cm cube portion. So originally it was 100, but we only took out 25. So first we'll find the total number of the moles. If we have 1.5 grams of a barium hydroxide, so first we'll find the moles in 100 cm cube. How to get the moles in 100 cm cube? Moles equal mass in gram divided by the molar mass. The mass in gram is 1.50 and the molar mass of a barium hydroxide, it's given in the question 171. So 1.5 divided by 171. This will give us the moles. So what is 1.5? 1.5 divided by 171. So that is 0.0087. And we only took 25 cm cube out. So this is 0.0087. Like in the 100 cm cube portion, it was 0.0087 moles. But we took out only 25. So in 25, how much it will be? You can work out by using a ratio. 100 cm cube solution contains 0.0087. So if we have 25 cm cube, how many moles will be there? X. Cross multiply, so you got 0.002 moles approximately. So when you simplify 0.0, so 1.5 divided by 171 was 0.0087 and then it is divided by 4. So 0.0021 moles will be there. Then calculate the concentration of a hydrochloric acid. So how we can work out the concentration of a hydrochloric acid? We have the moles of barium hydroxide. First, we'll find the moles of hydrochloric acid. So barium hydroxide and a hydrochloric acid, the ratio is 1:2. So if we have 0.0021 moles, it will be X cross multiply, so it will be 0.0042. Now we have the moles of hydrochloric acid and the volume of a hydrochloric acid is there. So if we need the concentration, it is moles divided by volume. So moles are 0.0042 and the volume is 18.75. 18.75 divided by 1000. That is 0.0187. So you got about 0.234 moles per dm cube. So this was a very long question. Usually you don't find this long questions related to the moles one. This was a rare question. Usually you have like 3-4 steps are there and directly you're solving the questions. This is a very rare question. Like in the past paper, you don't find this type of a question, stories are related to the moles. This was a very rare question, question 5, in which you're doing like a question as a series. But moles question are normally in the exam, you see a moles question like this, that all the steps are there, 4, 5 steps, and then you get the answer. So in this question 6, a silver chloride can be made. A silver chloride can be made by reacting aqueous sodium chloride with aqueous silver nitrate. The other products of the solution are there. Student started with 20 cm cube and 0.2. So he's having a concentration and the volume. Determine the amount of the moles. So how to get the moles? Moles is concentration times the volume. Concentration is 0.2 and the volume is 20 divided by 1000. So we have 0.2 multiplied by 20 divided by 1000. That is 0.004 moles of sodium chloride. The yield is 90%, like he's only getting 90% of this. Calculate the mass of sodium nitrate. How we can work out the mass? First, we'll find the moles of sodium nitrate. So 1:1 is the ratio between them. A sodium chloride and a sodium nitrate, the ratio between them is 1:1. Like 1 mole will give us 1. So if it is 0.004, it will be X. We get the same 0.004. But only 90% is what. After getting the moles, we'll find what mass we will get. So we have the formula moles equal mass in gram divided by the molar mass. So moles are 0.004, mass in gram we don't know. And what about the molar mass of a sodium nitrate? Sodium is 23, nitrogen is 14, and oxygen is 16 multiplied by 3. So 48. So it's 48 plus 14 plus 23, that sum will be 85. So the total mass of a sodium nitrate will be 85. So this is 85. 85 is divided, other side multiplied. So 0.004 when it multiplied 0.34. So we got 0.34 grams of sodium nitrate theoretically, but the yield is 90%. We are only getting 90% of this. Like we should get 0.34, but we are only getting 90% of this. So what is the 90% of 0.34? So 0.34 multiplied by 90 divided by 100. So 0.34 times 90 divided by 100, we got 0.306. So 0.306 grams, that is what we will get. Because it's 90% is a yield, 90% is we are getting, we're not getting the 100%. Question 7. To calculate the volume of the chlorine, calculate the volume of the chlorine using a formula. First, a relative formula of titanium oxide, relative formula mass of titanium oxide. How we can, you need a periodic table for that. Like using a periodic table, the mass of a titanium is there, and oxygen, it will be multiplied by 2. So oxygen is 16 multiplied by 2, which is 32. And the mass of a titanium, I guess it is 48. So 48 plus 32 makes 80. The total mass is 80. Number of moles in 400 gram. So moles equal mass in gram divided by the molar mass. The mass is 400 and the molar mass is 80. So 400 divided by 80 will get 5. Determine the number of moles of chlorine. How to get the moles of chlorine? We have the moles of titanium and we need the moles of chlorine. So we'll take a ratio between them. One molecule reacted with two. So the titanium oxide and the chlorine, the ratio is 1:2. So if we have 5, this will be X cross multiply. So we got 10. Then calculate the volume of a chlorine that reacted. So how to get the volume of the chlorine? Moles equal volume divided by 24. So if I need the volume, the moles are 10. Volume divided by 24. So 24 multiplied by 10, we got 240 decimeter cube. That's the volume of the chlorine gas which is reacted with oxide of titanium. So normally when we solve the question, like it's a formula, ratio, formula. The first part was additional, in which we have to use a periodic table and finding the mass. The next question. PCl5 reacted with lithium fluoride to form LiPF6. The mass of Li needed to form 3.05 using the following step. Calculate the number of moles of LiPF6 formed. So how to get the moles? Moles equal mass in gram. So first part is by formula, the second is by ratio, and then again the formula. So moles equal mass in gram divided by the molar mass. How much is the mass in gram? 3.04. What about the molar mass? It's given here 152. So we divide it by 152. That is 0.02. So we got the mole 0.02. Next is we need the moles of lithium fluoride. So we take a ratio between these two because LiPF6 moles we have and we need LiF moles. So we always take a ratio between the previous and the quantity now. So the ratio between LiF and LiPF6, the ratio between them is 6:1. So if we have 0.02, this will be X cross multiply. This will be 6 times the moles. So it will be 0.12. Calculate the mass of LiF. So how we get the mass of LiF? If we need the mass of lithium fluoride needed, so moles equal mass in gram divided by the molar mass. So moles are 0.12, mass in gram we don't know. And what about the molar mass of lithium fluoride? Lithium is 7 and the fluorine is 19. 7 plus 19 makes 26. So this is 26 is divided. Other side will be multiplied. So we got 3.12 grams of this compound. So first part we solve by formula. The second one we use a ratio. The third one again we use a formula. So it's a formula, ratio, formula. Some salts can be made by titration in a titration experiment. 20 cm cube of sodium hydroxide, exactly 25 cm cube of 0.1 mole sulfuric acid. Calculate the number of moles of sulfuric acid. So how to get the number of moles of sulfuric acid? Moles is equal concentration times the volume. The concentration of a sulfuric acid is 0.1 and the volume is 25 divided by 1000. So 0.0025. Determine the number of moles of sodium hydroxide reacted. So we take a ratio, like first we solve formula, then ratio. Ratio between sulfuric acid and sodium hydroxide, the ratio is 2:1. So if we have how many moles of sulfuric acid? 0.0025. So this will be X. So this will become twice of it. So 0.005. And then the concentration, if we need the concentration, it's moles divided by volume. 0.005 are the moles and the volume of a sodium hydroxide here, it's given 20. But that is in cm cube divided by 1000, so 0.02. So this will give us a concentration of a sodium hydroxide in moles per decimeter cube, which is 0.25. So this equals to 0.25 moles per dm cube. And if we need the concentration from mole per dm cube to grams per decimeter cube, what we do, we multiply by molar mass. So we multiply by the molar mass. So what is the molar mass of a sodium hydroxide? Sodium is 23, oxygen is 16, and hydrogen is 1, so it's 40. So 0.25 multiplied by 40, we'll get 10 grams per decimeter cube. So the concentration from mole per dm cube to gram per dm cube, we always multiply by the molar mass. Determine the volume of a carbon dioxide gas given off 25 cm cube of 0.4 mole per dm cube HCl. Calculate the number of moles. So we have the volume and the concentration. So moles equal concentration times the volume. So 0.4 multiplied by volume is 25 divided by 1000. This will give us the moles, which is 0.01. Then number of moles of carbon dioxide. So HCl moles we have and we need carbon dioxide. So first part we solve by formula. The second part we'll take a ratio. So we'll take a ratio between HCl and carbon dioxide. So ratio is 2:1. So if we have 0.01, how many will be there? X. Cross multiply. So this will be twice. So 0.02 moles will be there. Carbon dioxide is okay. The HCl moles, we are not finding HCl, we are finding carbon dioxide. So X should be carbon dioxide. And here we have 0.01. So when we cross multiply, this will become half of it because X is multiplied by 2. So 2x is equals to 0.01, or X is 0.01 divided by 2. So 0.005. And then we need the volume. So if you need the volume of a gas, it's moles multiplied by 24. So 0.005 multiplied by 24 will get 101. It will get 1.2 decimeter cube, but that is in cm cube. So multiply by 1000. We'll get 0.12 decimeter cube. That's 0.12 decimeter cube. We multiply by 1000. So it will become 120 centimeter cube. So these are questions related to the last week homework, the moles. So tomorrow we'll have a regular session in which we'll discuss the topic, the explanation. For physics, we'll have the block 2, chapter 2 topics. And for chemistry, we'll begin with the acid, alkali, and the salt.